So hello everyone, thank you for having me with this today. So this would be about Go-tchas. This is kind of playing on words. I think like each of us, this happened to each of us basically. It's like, you know, this experience when we are spending several hours or days trying to figure out why the code that is written perfectly well is not working like it was intended to do. So I like to cover some of those traps that we can find in Go language. Yeah, so I like Go in short. First of all, who of you have coded in Go like for over 3 years? And who has never coded in Go? Okay. Okay, so the expectations are set pretty high, I guess. Yeah, so in short, here are a couple of things. Maybe I guess most of you know those resources already. So those are places which I consider the best to start with, and to periodically come back to, especially code review comments are a great refresher regarding idiomatic Golang. Yeah, so we all know that in Golang everything is a copy, there are no references, except when someone is playing with unsafe, but let's talk about the regular usage of language. So we have to be careful when passing stuff to a function or to some method. Like method is just a syntactic sugar over a function. So under the hood, the receiver, so that in this case, so that struct which implements that method is passed as implicitly as a first argument to that function. So in this case, there is of course a bug that we are incrementing a counter inside a copy of a number, not a number itself. So if we run this, then that would not work. Demo effect. This should have happened. Okay. Okay. I didn't hit run. Probably no. Don't know what's wrong here, but let me try. No. I'm live. Yeah, okay. So before and after we have the same value. So to fix this, we have to change this to be passed as a pointer, so that we can refer to that instance of that struct. That particular one that we want to change, not to create its copy and act on the copy inside. So this one would work. And here one note that the pointer itself is of course passed by copy as everything in Golang, but this is a pointer, so we are passing an address to the memory. So we are acting on the real instance of a variable. Yeah, so let's go to slices, because like everything is passed by a copy, but there are some, maybe not exceptions, but special cases that I like to cover. So slices under the hood are structures that hold pointer. So when we pass a slice, we effectively do a shallow copy. So the slice variable itself is copied, but there is a pointer inside, which makes us act on the same underlying array which was in the original slice. There are many Go-tchas related to this, because when we modify this array, it can be reallocated, like when growing or not. Or if we reslice, there are some other cases. Like here's just an example of what can happen if we have a slice build.
Can you zoom in, please?
Sorry?
Can you zoom in?
Yeah, sure. If I figure out what. Sorry. Is it better now?
Yeah.
Okay.
Perfect.
Yeah. So thank you for asking for this. Yeah. So here is a slice of len 5 and capacity 5 built on an underlying array of 5 bytes. So this yellow guy is that underlying array, so the piece of memory that actually holds the data. And then if we reslice it in kind of Pythonic syntax, then we are using the same underlying array but pointing to some far distant place in memory. But this is still the same underlying variable in memory. The next thing we have to be aware of is that here is a kind of buggy way to find and copy digits out of a given file. So what happens here? We are basically reading the whole file into a bytes array and then looking for a given sequence of data that's interesting for us. And when we later on copy that data, then this, one moment, I think there is something wrong with this, but yeah, the basic idea is that we are referencing the same underlying byte. I'm missing a slide, so this is a fixed version actually. But yeah, so what I wanted to show is that if we were operating on a returned file's content and then resliced it to that portion of data that was interesting to us and return that one, then we were blocking garbage collector from returning the whole data read from that file, which was arguably kind of a leak, because we were only interested in returning a portion of that data, not blocking a memory of the size of the whole file. And the remediation for that is to copy out. So this is what's done here, that portion of data that's interesting for us. So to make a slice of that size is exactly the size of the data we want to return, and fill it with data, not return the original, in this case that would be B, so the whole data. So yeah, one thing more to know is how slices are growing under the hood. So if we run this code, what happens here is that we start with an empty slice and we append this 20 times just one value. So here is the first one is length, the second one is capacity, and then there's the contents of that. So we can see that it's doubled each time. One note to this is that this happens that way until 1024, and after reaching that threshold, the slices grows by 1/4 each time. It's not doubled after that size, after reaching that size. Yeah, so this is basically very ineffective regarding our runtime complexity, because we are reallocating the original slice. Like, for better clarity, I could also write out the pointer, so that would be changed under the hood. So we are reallocating after each growth. There is a new bigger array created, which is filled with data, and then this happens once again and again. So we could fix this with by either allocating, like in any way, by allocating upfront with the slice with, or the underlying array actually, with the known size of the whole bunch of data we want to write there. And there are two distinct calls to make here. So the first one creates a slice of length n, and it's like already of that size. So it exists in memory, so we can just refer to each item at each iteration. And the second approach is to create a slice of 0 length, but actually n capacity. So that's the third argument here. So in this case, there is n array allocated under the hood, but the slice has to be appended, so it has to grow in the process of writing to there, but it would never be reallocated actually in memory. So here is the same version, but like I for brevity removed prints from here, so that's better visible what's happening here. Here are all the prints restored. So we can see that in the first case, like we have the big slice from the beginning and just fill it with values. So the zeros are changed with actual values we are writing there. And in the second case, the capacity is from the beginning set to 20, and then we are just growing the underlying slice so that our kind of mask for viewing that data. Yeah, so the second structure that's actually kind of pointery, so it uses pointer under the hood, are maps. In fact, there are lots of pointers there, so we cannot even take the address of any item in the map. That's because the hash function points to buckets, and the buckets point to like the data is kept in, can be kept when the bucket is filled. Then the data can be kept in the linked list of other buckets under that. So we never really know the address, or should never reference that address of that item in the map. So that's why it's prohibited by the compiler. And by the way, this is the reason why when you are printing a map contents, the results appear to be kind of random. Because it just goes through all of those and without any particular order, and yeah, we cannot rely on the order of even on the order of insertion to the map. And the last structure that operates on pointers under the hood are channels. So first of all, like when should we use channels and mutexes? This is maybe not a gotcha, but kind of thing to keep in mind. So mutex is guardian for accessing the shared data. But as we know from Golang proverbs, we should do the opposite. So we should communicate, and this is what channels are for. So we can share the data using mutexes, but we are encouraged to use channels and to communicate and transfer ownership of the data, and rather than operate on the same data and try to exclude at given time the ability to access it, to avoid data races. Yeah, so this is kind of stolen from Ardan Labs, mentioned today earlier. I really like this page, so if any one of you wants to like recall some basics of channels, then this article is one of the best I've found covering channels internals. Yeah, so in this short table we can we can see how channels behave. So those are things that should be kept in mind when operating on channels. Like, I guess it happened to not only me that I was either writing to a closed or not initialized channel and wondering why my code is maybe not, like, panic is visible, but why it's deadlock somewhere. So this happens when we are operating on not initialized channels, on when we pass channels before the initialization. So this is something to keep in mind. The delivery guarantee is kind of related to how the channels behave under the hood. So I think we can just look at this and go to the next one. Yeah, and what I want to mention here is especially the last one, so that signaling with the buffered channels is considered code smell, because we either want to signal or there is some major synchronization problem with our code. If we want to signal, like, let's say 10 Go routines and not the other 12 or something like this, there is something else wrong. So that's a like indicator for need of some major refactoring, probably. Yeah, and in short, buffered and unbuffered channels are just like, I'd say that every channel is buffered, but unbuffered have just a buffer of size 0. So this is like mnemonic to remember what's there. And unforgettable marshalling problems, like every new Go developer struggles with marshalling and unexported fields. Especially, we can define JSON tags on fields, but they doesn't matter in this case. So any of those any of those unexported, so in Go that means private fields, will not be marshaled to a JSON string, and it doesn't matter if they are told to be reflected in JSON starting from uppercase or not. And there is also another problem. There is no either compiler or static analysis validation for JSON tags, or I haven't found, or maybe not. Maybe I was wrong. For sure there is no compiler validation, but some inters are actually catching this. Like, if you notice here, we have the same key defined for various fields. So kind of unexpected things happen. So like, we should expect, let me make this kind of bigger. So this is expected that well, there's something missing here. Why? Oh yeah, I was looking for this one. So when I marshaled this structure to JSON, then only 2 fields got actually marshaled into that data portion. So num5 as expected, but neither num6 nor 9 got exported due to that conflict of the field that's put here. So it's not that only the first or only the last will get exported, but none of them. And yeah, and of course there can be no tag at all, and this will be exported the regular way. Excuse me. And after that when we read that sorry, when we read that JSON string afterwards and create a structure out of that, then every field that was no matter if omit empty was set or not, like any unset field will be initialized to 0. So the 0 value of int, so in this case it's 0 as well. The next major topic are strings. So strings and runes. So basically, first, strings are immutable in Go. So every time I will go to this maybe later on. So for now, let's focus on the underlying stuff. So as we know, like only ASCII characters match to 255 bytes value. And any special characters need to be represented using more bytes. And in Go, there is a concept called rune. So any complex character can be represented by, like in UTF, in multiple bytes coding one single character. So the very common mistake is to iterate strings as bytes. In this case, we are just, so if we are iterating with range and then printing the values as characters, then we actually trim that 2-byte code into 1 byte, so we end up with A capital with some mark at the top instead of E with that how is it called, with that another special mark. So the correct way of iterating is to do a range for, but with the second argument, which will be automatically a rune, so a multi-byte value, and then we can see that this is the correct version. Yet another problem, if we iterate this just using the length, so length here returns the amount of bytes and iterates this as bytes, so we got 2 characters instead of 1, and neither of them is proper. And the other proper solution is to change string to a slice of runes, and then we can operate on that the normal way, getting the expected results. Yeah, so I mentioned that strings are immutable, so every time we concatenate strings, we have to allocate a new string in memory. So that can be very inefficient. Like here, those benchmarks are clear that the regular concatenation is very heavy, and the recommended way of that kind of operations on strings is using string builder. Another big topic is variable shadowing. So one common mistake is to define an error. This is the most typical, I think, value that was mistakenly typed this way. So the colon should not be there. We should assign to the real error that was real, or maybe the top level error that was defined earlier, because this is what we return at the end. Arguably, we could return nil here and do some other thing, but for brevity, I just come up with that simple example. The next gotcha of shadowing is kind of JavaScripty one, but like false or true are not identifiers in Golang. They are just consts. So we cannot do this at the top level. We cannot do const false equals true, because we would be caught by the compiler that we are overwriting the top level false constants that was defined earlier somewhere in std library. But we can define this is perfectly fine. We can define a local false variable and do some silly stuff. Yeah, so for that, this is kind of similar to that previous example of errors. So the better way of handling errors or to combining errors into some meaningful value, if we happen to have a case then where we want to iterate over some resources and do as much as we can and just remember those errors for logging or for whatever other action we want to do. But to do as much as we can, not to just short-circuit this and return or break after the first error. So there is a new addition, I believe this was added in 1.21 or 1.20. There is errors from S standard library has a new method is join. So yeah, this just it works like append for slices. So we can add an error and then return this, or this. The result also satisfies the error interface, so can be returned as an error. Yeah, timer leak. I think some of you may heard about this, but this appears good amount of times in the web in various like tales of various projects in the wild. Basically, the time after leaks. So if we happen to, like again, this code is too short to be that harmful, but if we happen to return before the time after ticks, so before that timeout, then the implicit timer that was created here, it's like not visible, but time after is under the hood is a timer instance, stays in memory until the timeout hits. So if we do this in a highly used environment, and if we get lots of requests, for example, and we do a timeout this way, then we can end up killing our memory using this like pretty simple way of stacking timers in the memory. So the fix, again I'm missing a slide, something weird happens. The fix for this is to use a timer instance explicitly, and to, like, we are creating timer equals something, and so we have a named timer variable. Then we in select case we reference timer.c, capital C, so that underlying channel, and we are reading from that. And the important addition is that we can defer timer close, timer reset close, something like this, to have this closed when we exited earlier than the timeout actually happened. This is what I call a panic bomb. So, well, Go routines, this is very counterintuitive, are not structured in a tree hierarchy. So if you happen to spawn a Go routine and it panics, then you basically crash the whole application. And there is no way of fixing that, at least using the standard library. There are some wrappers over Go routines that take care of that. So having recover even in main, that would not help in this case. We have to put this recover inside that function that panics. So either explicitly do go func and then recover and call F1, or like here do a recover block in F1 if we expect it may crash. And the for loop error. So the one that's finally to be addressed. This is arguably the first breaking change to the language, actually, in my opinion. Like, I get the point when like Go team argues that they did a scan of good portion of code on GitHub, and they are claiming they actually fixed a lot of applications with that change in language. basically it's that the iterator value in Golang is scoped to the loop, not to the iteration. So yeah, so if we happen to do this concurrently, then like this would print what's expected, this would not, because we are referencing the local. Actually, this is not the local variable to the iteration. So each Go routine would receive the copy of the iterator that was used to go through all of the values. So most likely, but this is a race, it will print all 5s. Sometimes it happens that one of those is one of the values in like the earlier ones, because it just relies on the order of execution of the main Go routine with the loop, and all those Go routines that are put on stack with like the particular that were meant to be executed with particular e value. So the common, not fix, workaround for that is to create, to shadow basically an iterator and create a local copy. In this case, this I is the actual iteration scoped values of like holding sequential values of I from the outer loop. The other way is to pass it by argument. That is also a valid solution, but hardly readable in my opinion. I like none of them is good. So yeah, basically in 1.21, so the current version, there was a change introduced which changes the way iterator is scoped. So that third option is kind of implicitly done under the hood, which results in supposedly fixing all the code in the wild, but we can turn off this, like maybe the other way. In 21, we can turn on this using Go debug loop var experiment, I believe. That was something like this. So we can turn this as an experiment and look if our application works. Before in 1.22 in February, it will be introduced as just how it works. And they are so cautious about this change that it will take effect only if the Go module version declared in Go mod is at least Go 1.22. If it's lower, then the code would behave the old way. So there are a couple of important things to remember about this. And yeah, interfaces. So this is about like the interface is yet another thing, like the fourth one actually, that has a pointer under the hood. So the interface itself is not a pointer, but it keeps pointer inside to the actual implementation of it. So we typically, or we commonly do some comparisons to nil for various reasons, but in those cases it will work. So here is undefined IO reader instance, here is defined but initialized with nil. So both of those work as expected. So we end up having like the nil comparison is expected, but in the third example, then we are actually assigning a real implementation. So that struct that implements that reader interface, but the RR variable was not initialized, so it's nil. The interface is not, so the comparison is true. We are comparing if the interface is nil, and it's not. But if we happen to run this, then we will end up in panic in the runtime. with one notable exception that in this particular implementation it will work. Because we are, and this is yet another gotcha, that until we actually refer to that R, there is no problem that we are calling a method on nil receiver. Like, again, the receiver is just the first argument, so there is no problem with passing nil as a first argument to the method. So this is why this works. But if we actually implemented that reader with some silly stuff like incrementing counter of red occurrences, then this one would panic, because we are trying to read counter out of a nil struct. Yeah, so this panics as expected. The order of differs, so those are just stacked, so they will print in the reverse order they were written. This is important to remember when doing something more complicated. And differ is scoped to the function, not to the loop or to the any other, like curly braces closed scope, just to a function. So, and this one we can see here is code by linters even. So basically this is a problematic one, because we won't close any file until the whole loop ends, and this is not what we wanted to do. And another problem kind of related to shadowing or to differs. In this case, the error, what do you think? What would be printed from that code? Like, we would expect that we would add more context to an error, but that would not happen, because the first statement is executed just after the whole body and before returning to the caller. So we already lost scope of that error variable defined here. It was local to the function, but we are now in the kind of outer scope. So the only way to overcome this or to work around this is to, like, the changes here. So here is an error, just a regular unnamed parameter, return parameter, but here we named that one. And this has scope big enough to be visible inside of the differ, so this would work, adding our more context to our error. Yeah, since most of you are experienced with Go, then I think this is pretty well known that some files are ignored and some are of special purpose. Also, there are two syntaxes of build tags. So if we like the one like the one at on the first line is a newer one. The second with plus sign is the older one. They are typically kept both in files, because we never know which compiler version would be used to build our sources. And either of those would work. Like, we don't have to combine build tags together with file name. We can, but it's not required. But we have to in case of negative conditions. So if we want to build for everything except Windows, then commonly we name the file _other or something like this. This is not a special name, this is just a file name. And the compiler only takes into account that build tag comments. And there are some low-hanging fruits, like Go has built-in unit tests, which are with the approach of table tests, which are very encouraged we are encouraged to write tests in that way, and this is not how we work all the time. So this is kind of maybe not a gotcha, but something that just we need to record ourselves from time to time. Also to use race detector if it's there, then it's for helping us. along with the debugger. I don't know why we shouldn't be allowed to use a debugger, but and also Profiler is a great tool to, like, yet another built one that we can rely on. And yeah, Łukasz mentioned Go-tchas on his presentation, so I won't repeat this. And Golang CI lint is not a linter itself; it's kind of aggregator for linters. If we go into their page, then we can see that there is like a couple dozens of linters available out there, more or less reliable, and some of those are introducing a lot of noise into our build system. So my opinion is that we should not add them all, because we will soon end up like being blind for the errors or warnings that are printed out, or we will change our CI so that it does not return with an error if the linters are complaining. It's much better to use some of those, and this is how the Golang CI works by default. So it enables only some of those most reliable. GoVet is a built-in one. Static check is one of my favorite personally. It's even very worth of reading static checks errors, that things that it can complain about, and how the pieces of code should be rewritten to be correct, let's say. And there's also GoSec, which is not a default one, but it's kind of like static check, so it's it does not do the analysis of dependencies like Go-tchas, but it does basically a static analysis of the code itself, but from the kind of security point of view. So it can complain about using a path without a file path clean, or of not sanitizing some arguments or something like this. So those kind of things that we may not necessarily think about in our daily work, but are worth to remember and to take care of. Yeah, and my recommendations for continuous learning of Golang. So those are the excellent sources, like Golang Weekly, so our weekly blog of Golang team that we can read, the Go blog with very detailed and in-depth articles, and Go Time podcast, which is one of the best resources. Like they are also discussing, like we today, for example, GopherCon, but they were discussing in their last episode the GopherCon that was in US, so also worth listening. Here is QR of those slides. One thing that GoTalks HubSpot, this is an official way of publishing. Like preparing this presentation, I learned that .slide and GoPresent tool. So Golang team created that tool for creating presentations, and I'm not sure if you noticed, but this how those slides look is not a customizable thing. They just look this way, and I have no control over how text is formatted. But this is the way how the official presentations commonly look. So there is a tool called GoPresent. Is in official Go, in extended Go packages. So here is the documentation on how to write this. So basically we are writing kind of markdown and then running a server that can understand this syntax. This is run on my local host here. We can just present the slides. And there is a nice feature related to that the official page at gotalkshubspot.com is capable of scrapping any of presentation that's in that format that was placed on GitHub. But apparently they have some problems recently with GitHub API, and if you go into this link, you will probably end up with forbidden 403 HTTP error. Yeah, so I don't know when they are going to fix this, but this is a common problem when I googled for that. So anyway, under GitHub and my user and in the Tox repository there is that slide, so it's easy to decipher the presentation source from that link as well. Yeah, and I think that's all from me today, so thank you very much. I hope you don't have any questions, but but if there are any, then I will try to answer.